Okay, so we are moving on to the next section. All right, we're getting away from equations, and we're going to be getting into inequalities. All right, so we are starting Chapter 3, Section 4, and we're going to be solving inequalities using addition or subtraction. Okay, the first thing I need to do with you guys is I need to talk to you guys about what an inequality is and what the solution to an inequality looks like. AJ, put your shoes on, dude. All right, so let's talk about equations versus inequalities. Okay. I'm just going to kind of split my page here. All right, an example of an equation is going to be something like x plus 5 is equal to negative 3. All right, the reason it's an equation is because we have an equal sign. Equal sign between two expressions. I do have the pencil sharpener if you want to use it, sweetie. You have the pencil sharpener if you want to use it. You don't have to. I'm just letting you know, though. All right. So this is an equation. If I was to change that same equation into an inequality, it might look like x plus 5 is less than negative 3. All right. So what we've done, instead of an equal sign, we have an inequality symbol between the two expressions. We have an inequality symbol between the two expressions. All right, so from a visual standpoint, that's the difference between those two. Let's talk about our inequality symbols. We don't use them all the time, so we kind of have to remember what they are. Well, what is this one that I drew there? What is that inequality symbol? Sophia? That's a less than. So we read these from left to right. All right, the smaller side is coming first. That's the less than. All right, what is this one? Brendan? That's a greater than. All right, what's another one? Amanda? Pardon me? Nope, that's not an inequality symbol. Colin?
Isn't there not equal to?
Nope. I mean, there is, but that's not an inequality symbol. Alex? I like you guys are trying, though, so please keep trying. Even if you're not right, I'm good with that. And what does that mean? Yes, but what does that mean? If you're not sure, have somebody help you. Okay, have somebody help you. Excellent, it's exactly right. So we have less than or equal to. Excellent. What's the last one? Valentina? What does that mean? Excellent. Greater than or equal to. So there are the 4 possible inequality symbols. You guys cool so far? Okay. So what I want to talk about are solutions. So if we talk about solutions to equations, because I want you guys comparing something you know to something that maybe is new to you. So a solution to an equation is going to look like x equals 3. That's a solution to an equation. All right, if we talk about solutions to inequalities, this is going to look something like x is greater than 3. Makes sense, doesn't it? Okay. One of the things that we do for solutions to inequalities is we graph them. All right, so I want to talk about graphing solutions to inequalities. Okay. So let's talk about graphing solutions to inequalities. And I'm just going to graph that solution. All right, first of all, it's going to be on a number line. And there are 2 elements that goes with our graphing. All right, I'm going to do my graph over here, and I'm going to give you guys a description of what those 2 are. So give yourself some space. Maybe do the graph kind of off to the side. So we have a number line. It's on a grid line. Always find your 0. Put some increments on there. If you're counting by ones, I don't need to see anything other than the number that we're graphing from. Okay. The first thing we graph, well, first of all, this 3, the number that's in the solution, I call this our start number. Because it's where our solution, all the possible solutions, all those x's, it starts there. Because if you notice, there's just not one answer to this. This says x is greater than 3. So all my x's that are possible solutions to whatever that equation was, and we'll solve equations today, all those possible answers are all greater than 3, because that's what that says. All right, so first of all, that 3, that number that's within the solution, that's our start number. So the first thing that we graph are the dots. All right. The 2 possibilities are one that looks like this. This is called an open dot. This is when we have a less than or a greater than. And this is when the start number, not part of solution. So our solutions start there, it does not include it though, because there's no equal to part, right? The other possibility is a closed dot. This is for a greater than or equal to, or a less than or equal to. Less than or equal to, or greater than or equal to. And this is when our start number is part of solution, because it's equal to as well. All right, so what I want you guys to do is I want you to graph that dot at your start number. So our start number is 3, so I'm going to find 3 on my number line. So the first thing I'm going to do is I'm going to graph the dot. What dot? This is the dot at start number. What type of dot is going to be on my 3 based on ours? Sarah? An open dot. Why? Excellent. Okay, the second thing you are going to do is our shading. So the shading, what this represents all possible x values. Or whatever variable that you're using. It represents all possible x values. So if I go back to my solution, I have x is greater than 3. So what are all of my values of x in relation to my 3? Cameron? 4 or more. So they're all going to be bigger than my 3. So I'm just going to shade. If you want to use a different color, you can. If you just want to thicken the line, have an arrow at the end. It doesn't need to be super long. Enough that I can see the dot and I can see which direction you're shading. An arrow at the end of the shading. Let's not have this be too messy. Yes. Yeah, you can do this in pencil and just make the line bolder. Absolutely. You can do it in a different color if that's more helpful to you. Colin, sit up, please. Questions on this so far? All right, so I'm going to have you guys graph one more by yourself, and then we're going to talk about solving equations, and we'll do more graphing. Okay? You guys cool so far? Okay. So I want you to graph these two inequality solutions. So my first one is going to be z is less than or equal to 4. So go ahead and graph that, and I'll put the second one up. So again, make sure your number line is on a grid line. You're using a ruler. Find your 0. You can move your 0 anywhere you want to on this graph to accommodate the numbers that you need. If you're just counting by ones, I do not need to see what you're counting by. I just need to see 0, and I need to see your start number. If you're going to count by 2s, tell me positive 2 and a negative 2 on either side of your 0, or whatever you want to count by. Actually, I'm going to put a third one in there. God bless you. All right, somebody graph, tell me what to do for that first one. Matthew? Excellent. Excellent. So I'm going to shade to the left. So Eddie, this is what I will do sometimes instead of colors, is I'll just make that line a little bit bolder. All right, make sure there's an arrow at the end. It does not have to go to the very end of your number line. Make sure I can distinguish between the dot and your shading. How about the second one? Alex? Excellent. Excellent. Go to the right. Excellent. How about that last one? Sophia? All right, I'm careful on this one, you guys. What are all my variables, Sophia, in relation to that one? Are they bigger or smaller? They are bigger. Excellent. If you notice, this one, the variable did not come first. All right, so you have to kind of pay attention to which side of the inequality is facing the variable. And Sophia's absolutely right. The bigger side of the inequality is facing our variable, which means all of our variable numbers are bigger than that 1. Nice job. Questions so far? Okay, so now let's talk about solving inequalities. We're not going to do story problems today. We're going to do that tomorrow. So we're just going to base today is just the skills of it, okay? So for inequalities with addition or subtraction, the process of solving is exactly the same as equations. It's exactly the same. Now, when we have multiplication or division, that does change. We have a little bit of a change that we have to accommodate. But for addition and subtraction, it's exactly the same. And when we get to story problems tomorrow, we literally do exactly the same thing for equations as we do inequalities when we're setting up our game plan and story problems. The only difference is the inequality symbol versus the equal sign. Okay? All right, so let's just focus today on solving an inequality. So I want you to solve and graph, and then we're going to talk eventually about checking our solution. Okay. M plus 5 is greater than or equal to 10. So all of you solve that, please. Remember, you're doing exactly the same thing you would if this was an equation, the process. Someone tell me what to do. All right, Valentina, go ahead. Excellent. So I got M is greater than what? Excellent. All right. So now I'm just going to graph it next to it. Actually, I'll graph it below it because I want to show you how to check. And that's where my room is. So Valentina, explain to me how to graph this. Talk louder, sweetheart. Yep. Yep. Okay. Not 10. Yeah, so don't forget, I'm glad you said that. Remember, we are graphing the solution. So we don't care about that 10 anymore. We're just graphing that solution. So we need to find that 5, right? That's the biggest mistake that I see is that we go back to that original constant on that right side in the original inequality. Don't do that. We're graphing the solution. All right, so now, what type of dot am I going to have, Valentina? Why an open dot? Okay, what inequality symbol is it? Closed dot, because it is equal to as well, isn't it? What are all my m's in relation to that 5, Valentina? Are they bigger than that 5 or smaller? They're bigger because the bigger side of the inequality symbol is facing the variable. If the variable is coming first in our solution, how many of you guys notice the inequality symbol is also an arrow, put your hand down, in the direction of your shading? How many of you guys notice that? That's a little bit of a hint, right? If your variable comes first in the solution, put your hand down. It points in the direction you need to shade. However, if your variable is not coming first, you can't do that. AJ, sit up. All right, so I really still want you saying to yourselves what side of the inequality is facing my variable. The bigger side, so my variables are bigger than that number. Brendan. No, it's not equals 5. It's an inequality. It's So you have to switch it. I'm not doing equations. We are doing inequalities. So you can't change that to an equation because that's not what this is. So make sure you're leaving as an inequality. Ada. What's wrong? This one here? Yep. What about it? Do you understand why the shading is on the right? All right, so this is an example of what I'm talking about. If the variable doesn't come first, that whatever direction that inequality is pointing does not help you. All right, so that's why I do want you guys saying to yourselves, what side of the inequality is facing my variable? Alex. What else is there to solve? I just want to solve the equation. Isn't this the solution to the equation? I mean, all my m's that make this true, all my m's that would make this inequality true have to be bigger than my 5. So this is just the graph of that solution. There's nothing else to do. Molly. You can, but be very careful that you keep the side of the inequality that faces the number the same. Like the number has the smaller side facing it, so make sure when you reverse it, that you reverse the whole thing. That's my only suggestion. But you guys are smart enough just to say, all my t's are bigger than my 1. You can if you'd like to, but I know you guys are smart enough to make that connection. Okay. Let's do another one, and then we're going to talk about checking our solution, okay? So let's solve, graph, and check. Now, if they don't ask you to check, you do not have to, all right? But if they do, I want you checking. So I have negative 10 is greater than x minus 12. So all of you solve it and graph it, and then we'll talk about checking. So this is what you should have. So you should have 2 is greater than x. Again, as Molly said, if you want to switch the order in that, you can. Molly, if I switch that, what's it going to look like? No. X is less than 2. Make sure you keep the side of the inequality that's facing the variable exactly the same when you switch it. So somebody tell me, Nico, tell me how to graph this now. Excellent. Excellent, because all my x's are less than 2. How many of you guys are cool with solving and graphing those? All right, let's talk about checking the solution. This is much different than checking a solution to an equation. If this was an equation, negative 10 equals x minus 12, and we got x equals 2, how would you check that solution? So this was an equation, and it said negative 10 is equal to x minus 12, and our solution is x equals 2. How do I check that? Coral, how do I check it? Excellent. That's exactly right. I'm going to take that x, that 2, I'm going to put it in for my x, and I'm going to look to see if the left side equals the right side. Okay. Problem is, I can't do that here because I've got lots of possibilities for my variables. So really what I'm checking is we are just checking the shading. So I'm not checking my math. I'm checking the shading that I did. Alright, so what you're going to do is choose a number in the shaded area. It does not matter what number. Make it easy on yourself. Alright, what number would you like to choose from the shaded area? Amanda? Let's choose 1. So let's say x equals 1. Alright, well we are going to substitute that into the original and to see if it makes it true. So substitute that value into the original inequality to see if it makes it true. Alright, so I'm just going to do this right here. So my original inequality was negative 10 is greater than x minus 12. So if I substitute that in, I have negative 10, and I'm going to put a question mark over that greater than symbol. Is that greater than x plus a, not x, 1 plus a negative 12? Alright, so I have negative 10, positive 1 plus a negative 12 is a negative 11. Is this true? Is negative 10 greater than negative 11? Matthew?
Yes.
Yeah, this is true. So, my shading is correct. If you shaded in the wrong direction, alright, and you put a number in from your shaded area, if we happen to put a 3 in because we shaded on the wrong side, if you put a 3 in, it would not make this true. So you know you shaded the wrong way. Fix your shading. Does that make sense to you guys? Questions? Alex? You need to, what does this say? Anything. Any number in the shaded area. Quite honestly, I would have used 0. Because there's no math to use of 0, is there? Isn't 0 plus a negative 12 negative 12? Any number you want in there. You make your life easy. Put an easy number in there. You could put negative 10 in there. Right? Any number in that shaded area. Okay? It does not have to be a specific number. But you can't put the 2 in. You can't put the start number in. That does not help us. So it has to be from the shaded area. You guys cool with that? I'm happy that you guys are asking questions, so thank you for asking questions. And my odds, you